We are going to be learning about databases, SQL, Excel, Power BI, and Python to help you enhance your skills and become more prepared for the data analyst role. Do you ever wonder how Twitter, YouTube, Facebook, and Instagram know what to advertise to you? What do they do to show you things you're interested in or change things based on your preferences? Data on your preferences, complaints, interests, sites you visit, pages you like, and so on allows them to know everything about you. The key to success is data. Data is information, especially facts or numbers, collected to be examined, considered, and used to help decision-making. Here is what the data analyst does. Data collection. Data analysts collect many types of data from a variety of sources such as databases, spreadsheets, APIs, websites, and many more. In this way, they ensure that the data is accurate, complete, and relevant to the task at hand. Data cleaning and preparation. Missing values, errors, and inconsistencies are common in raw data. Data analysts prepare the data for analysis by cleaning and pre-processing it. Among these tasks are removing duplicates, filling in missing values, and standardizing data. Data analysis. Analyzing data involves using stat and analytical techniques to uncover patterns, trends, and relationships. Analysis may be performed with Excel, SQL, or specialized programming languages like Python or R. Data visualization. To present their findings in a clear and understandable way, data analysts use graphs, charts, and other visualizations. The insights can be more easily understood by non-technical stakeholders when they're visualized. Visualizations are created using Power BI or Tableau. Report generation. A data analyst creates a report that summarizes their findings and insights. Analysis methods, key takeaways, and recommendations are often included in these reports. Business insights. The ultimate goal of a data analyst is to convert data into actionable insights that can help businesses or organizations make informed decisions. A data analyst must identify opportunities for improvement, suggest strategies, and provide data-driven recommendations. Performance tracking. To assess the success of various projects, campaigns, or business operations, data analysts monitor key performance indicators, also known as KPIs. Metrics are tracked over time to identify areas that need improvement. Data-driven decision-making. By providing evidence-based insights, data analysts play an important role in influencing decision-making processes. In addition to assisting stakeholders in selecting the most effective course of action, they help stakeholders really understand how different choices might affect their outcomes because of data. Predictive analysis. In order to build predictive models, some data analysts use advanced techniques. Based on historical data and patterns, these models predict future trends, behaviors, or outcomes. Collaboration. There's often close collaboration between data analysts and many other team members such as data scientists, business analysts, and domain experts. Communication is the key to understanding business needs and presenting findings effectively. Ultimately, data analysts help organizations succeed by turning data into actionable intelligence that helps guide decision-making and achieve business objectives. Third, query language is a domain-specific language used for managing and manipulating relational databases. It serves as the standard language for interacting with databases and is used for tasks such as creating, querying, updating, and deleting data within a database. In order to learn SQL theory and practice, let's first understand the basics of databases. If you're not already familiar with them, you will learn now. If you already know, this will be a quick recap for you. Databases are organized collections of data that are designed to store, manage, and retrieve information efficiently. They are crucial components of modern software systems used for various purposes ranging from simple data storage to complex data analysis. Here are some basics about databases and data attributes that you should know. Number 1, databases. A database is a structured collection of data that is organized, stored, and managed in a way that allows for efficient retrieval and manipulation of information. Databases are used to store various types of data, including text, numbers, images, videos, and many more. Number 2. Data attributes. Data attributes, also known as fields or columns, are the individual pieces of information that are stored within a database. Each attribute represents a specific characteristic or property of the data being stored. For instance, in a database containing information about customers, attributes could include name, age, address, and much more. Number 3. Types of data attributes. There are different types of data attributes, each suited for storing different kinds of information. Text string, used for storing alphanumeric characters such as names, addresses, and descriptions. Numeric, used for storing numbers which can be further characterized into integers, decimals, and much more. Date and time, used for storing date at time or timestamp information. Boolean, used for storing true, false, or binary values. Binary, used for storing binary data like images, videos, or documents. Enumerated, used for storing a predefined list of values like male or female. Number 4. Primary key. A primary key is a unique identifier for each record row in a database table. It ensures that each record can be uniquely identified. It helps in maintaining the integrity and consistency of the data. Commonly used examples of primary keys are customer IDs, product IDs, or social security numbers. Number 5. Data types. Each data attribute has a specific data type associated with it. Data types define the kind of values that an attribute can hold and determines how the data is stored in the database. Examples of data types include integers, strings, dates, and more. Number 6. Data integrity. Data integrity refers to the accuracy, consistency, and reliability of data stored in the database. Databases are designed with constraints, rules to enforce data integrity, such as ensuring that primary keys are unique and the data values conform to specific formats. Number 7. Relationships. In relational databases, data attributes from different tables can be related to each other through keys. Common types of relationships include one-to-one, one-to-many, and many-to-many relationships. These relationships help in organizing and retrieving related data efficiently. Number 8. Databases management systems. A database management system is a software that provides an interface for users and applications to interact with databases. It handles tasks like data storage, retrieval, manipulation, and security. Popular DMS include MySQL, PostgreSQL, Microsoft SQL Server, and Oracle. Anyone involved in data storage and management must have a solid understanding of databases and data attributes. Applications ranging from simple data storage systems to complex enterprise-level software solutions rely on them. Now here's a comprehensive overview of SQL. Number 1. Relational databases. SQL is primarily designed for relational databases which organize data into tables with rows and columns. A relational database consists of multiple tables, each with a unique name and predefined structure. Within the tables are columns, which is for use for the data attributes to store the data. Number 2. Basic SQL commands. Select. Select retrieves data from one or more tables based on the specific criteria. Insert. Insert adds new rows, records into a table. Update. Update modifies existing data within the table based on specific conditions. Delete. Delete removes rows from a table based on specific conditions. Number 3. SQL data types. Data types define the kind of data that can be stored in a column, such as integers, strings, dates, and more. Common data types include integer, varchar, date, float, boolean, etc. Number 4. Querying data. The select statement is used to query data from tables. You can use conditions where clause to filter results, and you can order results using the order by clause. Number 5. Filtering data. Where clause is used to filter rows based on specific conditions, logical operators and/or not, and comparison operators equal, greater than, less than are used in conditions. Number 6. Sorting data. The order by clause sorts query results based on specific columns in ascending or descending order. Number 7. Joins. Joins combine data from multiple tables based on related columns. Common types of joins include inner join, depth join, right join, and full join. Number 8. Aggregation. SQL supports aggregation functions like count, sum, av, min, and max to perform calculations of group data. Number 9. Grouping data. The group by clause is used to group rows by one or more columns, is often used in combination with aggregation functions to summarize data. Number 10. Subqueries. Subqueries are queries nested within another query. They can be used to retrieve data for conditions, calculations, or comparisons. Number 11, updating data. The update statement modifies existing data in the table based on specific conditions. Number 12, deleting data. The delete statement removes rows from a table based on specific conditions. Number 13, creating tables. The create table statement is used to define the structure of a new table, specifying column names, data types, and constraints. Number 14, constraints. Constraints ensure the data integrity by imposing rules on the data stored in tables. Check constraints include primary key, foreign key, unique, not null, and check. Number 15, indexes. Indexes improve query performance by providing a fast way to look up rows based on indexed columns. Number 16, views. Views have virtual tables created by querying one or more existing tables. They can simplify complex queries and provide a controlled access mechanism to the underlying data. Number 17, transactions. Transactions ensure data consistency and integrity by grouping SQL operations together. There's something called ACID. ACID stands for atomicity, consistency, isolation, durability. These properties define the behavior of transactions. Number 18, database management. SQL is not only about querying data but also about managing databases, including creating, altering, and dropping databases and tables. Number 19, database administration. Database administrators, DBAs, are responsible for managing and maintaining databases, including performance tuning, backup, and security. Number 20, SQL variants. Various data systems implement SQL with slight differences. The most widely used variants are MySQL, PostgreSQL, SQL Server, Oracle, and SQLite. Number 21, SQL limitations. SQL is designed for structured data and relational database. It might not be suitable for unstructured or complex data types. To summarize, SQL is a powerful tool for working with relational databases and understanding the fundamental concepts and commands. It's essential for anyone involved in data management, analysis, or software development. To install dbeaver. dbeaver is a free and open source universal database tool for developers and database admins. So the reason we're going to install this is to run our SQL commands and learn more about it. So let's get started. Just a quick overview. So dbeaver is good because of its usability. The main goal of the project is to give you a program UI which is carefully designed and implemented. It is free, it is open source. It allows for various plugins. It may handle any external data source which may or may not have a JDBC driver. And it also offers multiple features. So what we're going to do now is we're going to go to download. And then we're going to install it for the system you're on. So it could be one day Windows, Mac, or Linux. For me, I'm going to do this Mac. So as you can see, it is downloading now. Just give it a moment for it to download. And once it's done, you're going to open the file. You're going to move it into your applications. Yes, you can just say keep both. And now what you're going to do is you're going to go here. We're going to put dbeaver. This is the application you're going to open in. As you can see, it is getting started, and the best part is, if you're learning SQL, you don't have to pay for it anything in Pocket. Now, do you want to create a sample database? Please press yes, because that's what we're going to use to learn. Do not send. So as you can see now, you have this, and then what you're going to do is you're going to click here. Okay, saying you got to download the driver files, which is good, so you can click on download. And then you can see you have bunch of tables, which is album, artist, views, indexes. So what we're going to do now, and you can look into the project as well, we're going to open our SQL, and we're going to go back to our database, and we're going to write a simple command. Select, okay, we're going to say, let's say, album, look into your columns, album, ID, from, album. Okay, and then you're gonna click here. Now this is the SQL terminal, and then you can see what the data are in. So this shows you how you have successfully downloaded and are using dbeaver. So now let us get started to learn SQL from the sample database. What we are going to be doing is we're going to be using different SQL statements to learn about SQL. So let's get started with the first most common statement, which is a select statement. So the select statement just tells you, or more of to the system, okay, this is what you need to return back to me. So what we're gonna do is we're gonna do this wildcard star. So this star would give you everything from the table that you're looking for, but you have to tell it what exactly are you looking for by looking at from. So give me everything from the album, let's say that table. So now what we're gonna do is we're going to run it. And as you can see on the bottom, the album ID has come up, the title, the artist ID, and everything else. Now what we're going to do is we're going to remove this, and we're going to tell it to give us only distinct values. What distinct value means is what the word says, only the unique values. Okay, so you see these things also come up. So give me the distinct values of, let's say, of artist ID, because as I can see here, there are some repetitions. So you have to correctly list out the query. And again, where are we getting this from? We're getting this from the the album table. Okay, so before we move on, you see how we got 200. Now with this, we are going to get less than 200. Because it's going to give us only the IDs, but as we can see, the IDs are unique, which means that each ID, there was no distinct ID out there. Okay, so now we're going to move on to the next statement, where. So the where clause is just a way for you to tell, okay, get me this from here, where there is XYZ. So let's use something else. Maybe let's use artist this time. So let us look at the columns. So we have artist, we have name. What about customer? With customer, do we have, okay, so customer, we have more variety. We have the address as well. Just looking at the address type, okay, the data type is varchar, number is 5. I'm thinking, okay, how about we do this? Select customer ID. From customer. Let's see what kind of data do we have before we actually get started. So before we move on, quick thing, the reason why I didn't use artist was because artist had only 2 columns, only 2 data attributes, but I wanted more data to play around with. So let's click on run. Let's see what comes up. Okay, and customer ID came up. What happens when we do this? Let's see what kind of data is there. First name, company, address, city. How about Oslo? How about we do Sai? So what I'm gonna do here, I'm gonna say where, condition, and then I'm gonna say city. Okay, you see city is equal to, I'm gonna copy paste in. Okay, and then semicolon. Let's run it. Okay, so we only found 2 records, so from the big data set, only a subset came. So this was for the where one. Now let's learn more about and, or, and, not. Okay, so these are the conditions that you can use within your where. This is more of like the logical statements. Give me city where it is this, or give me a city where there is stat. What I'm gonna do now is I'm gonna go back. I'm gonna play around the data a little bit more to see what other filter I can introduce. Country, Brazil, phone number. So customer is good too. Let me try to look in my employee data. What kind of, okay, so this is also good. We have employee ID, first name, last name, title, hire date, address, city, state. Let me look at employee data. Okay, so we have only 8 records showing up in the employee data. Let's see if all of them are in Canada. Is there any repetition that we can use? Not really. What about the city? Okay, so how about we do this? You use 2 cities from Canada using and or. So let's do where city is equal to, let's say, city A. Or we could have also used, and, but we're just playing around. Let's use Lethbridge. Now, if a spelling is one way and you put it another way, it's not going to run, so you have to be careful with it. Alright, let's see what comes up. Oh, I have an error. Let's see what I did wrong here. Oh, yep, this thing. Yeah, instead of equal, I put this random thing. Let me just space it out. Okay, perfect. So you see how there were like more records, but now it's all giving us either or. And now if we replace this with and, nothing is gonna show up. And just let me do this. And the reason why nothing's showing up is because as employee can't live in one city and the other one as well. Okay, so this one was for city. Now let us do order by. Order by is another good one. So let us use this data and see order by, let's say, what attribute? Yes, one to city, let's just city. And then order by city in ascending order. Now let's use ascending order A, S, C. And now let's run it. So you see how when you look at the city, everything is in ABC order. So that's what order by means. Now let us do one min and max value, syntax. Using that, let us look at maybe employee database. Let me see what we can play around. How about we try to do employee ID, where, let's do min, and then let's put the column name of employee ID. So this will tell us when we run it, which one is the minimum employee ID, which we can see is 1. How about if we wanted to see the maximum, not the minimum? So when we do that, we will get 8. So 8 is the maximum value. Okay. So this is how you find min and max, by putting it into the condition. Now what we're gonna do is, let's do count. If I wanted to count how many employee ID I have, count, you put it here. It shows you 8, okay? And if you wanted average, you would use, I don't know if you would want to do average for employee ID, but just for the sake of it, what I'm gonna put here is average. Oh, the reason why you are getting this error is because you did not put the within the parenthesis the column name, which is really critical. Okay, so I think we covered most of the critical syntax. I'm just going over my notes to see which one we didn't cover, but it's good to do. Let's do a group by, but this time let us use a different data set. So we have invoice. Let's see what kind of attributes we have in invoice. Invoice ID, customer ID. Okay. So what I'm going to do now is I'm going to go to customer. And I am going to select everything so we can see what kind of data exists here. Customer ID, first name, last name, company. Okay. How about we group by everything by the city? And we put city. Let's see how our data looks now. Okay, so our data is organized by the city now. And order by we already did. Okay, so these are the main commands that you really need to know when you're using SQL for basic syntax. We are going to be learning Excel. Before we get into the functionality that Excel has to offer by doing examples, let's focus on what Excel has to provide. So let's start from the tabs on the top. So if you look at the home, it gives you multiple functionalities to change the font, to do alignment to your text, to do conditional formatting. Conditional formatting meaning showing greater than, less than, between, equal to, adding data bars, color scales. Also formatting as different table, doing cell style, changing around the colors, inserting, deleting, and sorting and filtering, along with find and select. If we get to the Insert tab, it shows you how you can use pivot tables. You can add images, different shapes, different icons. Also, you can have multiple charts which you can use, for example, the waterfall, funnel, tree map, along with different kind of bar charts. You can also draw depending on what functionality you have. Page layout, which shows you the margin. It also shows you the orientation, shows you the size, depending on how you want to change the Excel. Also now, this is the most important one, formulas. So there are multiple formulas which you can use, some average, count numbers, max, min, to from simple to like super complicated. If financial ones, for example, you can do the effort, the duration, if you want to find out what duration it took, along with the rate, PV, yield, logical, and if error, not, or, different kind of text formatting, search, write, replace, date and time, date value, days, finding out the time it takes from one day to another, 2 hours. Looking up things, for example, address, areas, choose, filter, math, and trig. This involves costs and different kinds of trigonometry functions. Then there's stats, which you would averagely use for any stats, engineering, cube, information, compatibility. And then it comes down to using different kind of formulas, and if there is any error checking that you need to do. Then different ways to deal with your data. You can sort it, you can filter it, you can change it, you can get the data validation in. Then comes the review, as just like if you need to get some external information. And view is how you want to showcase your data. So now that we have gone through this, let's get started to do samples. The first one we're going to focus on is add. So in order for you to do add similar to any other function that you're using, do equal, add the function name, and then what data you have here, and then it comes. Also, you don't have to make it too complicated. What you can do is you can do average as well, right? And average. So if you go to average, what you can see is average is another way you can find it. So it's not just sum that you can use, but average as well, or any other function that you use. Just always remember you have to do equal. Equal, and then the name of that particular function. It's a filter, is a sum, whatever you're using, but it has to have equal. Now let's move on to fill. Now what happens with fill is that you don't have to drag everything right. Now this is a very simple example. This is a table. Then what happens in real life scenario is you have thousands of records. You're not really going to drag everything down. So what this allows you to do is, if I go here, double click, you see how everything comes up. Similarly, this thing by now is empty, but I'm going to get it populated. Okay, and that's a great part of it, like what we learned before, functions. If you have a function, you can use one function throughout multiple records. You don't have to just use it for one record, and it automatically populates for you. Let's move on to the third one, which is split. Now, what happens with split is that sometimes you get multiple records that are together, so you need to break them out. That is where you're going to be using the split function. So what I'm going to do is I'm going to click my data. This is my data. I am going to go to the data tab. I'm going to go to split text through columns, delimited. Next, so this is showing at comma. Next, here I'm just going to say D because I want the data to be formatted. Okay, in this format. So you see how everything was together, but now we have split it out. Let's move on to the next one, transpose. So transpose is a great function because what this allows you to is just like change the way your data is looking. So if I copy this, I go here, paste special transpose. You see how this shows up? Similarly, there are multiple ways to transpose your data. Let's move on to the next one. Number 5, sort and filter. So with sort and filter, this is also great functionality that you have multiple records and you can organize them. So what I'm going to do now is I'm just going to click on December and then I am going to sort it. Sort. So you see how is from the lowest to the highest? Similarly, what I can do is I can do highest to the lowest. And that's not the only thing that happens. So what you can do is you can filter, sort, you can sort on multiple values. Sort by department, let's say, and then add, then sort by category, then sort by October. Smallest to highest. So you see how everything is organized now by department, daily, meat, produce, and then category. Let's move on to the next one now. Tables. So tables are like a critical function because a lot of times you're going to get the data which you have to put into a table format and you have to organize your data. You have to make it look nice and pretty. So what I'm going to do here is I'm going to go to the home. I'm going to format table. Yes. So you see how this got formatted. Furthermore, I can change it around, right? It doesn't have to be a particular color. Depends on how you want to showcase your data. Now, if you want to enter new data, what you can do is you can go here, insert, row below, or if you want to do it on the bottom, you can do it on the bottom. Or if you want to add another column, then what you can do is you can right click, insert column to the left or right. Now let's move on to the next one, slicers. So slicers are a great way for you to get more input on your data. So for example, we look at this data set. Now a lot of data, but what if I just want to, what if I just care about meats, right? So this helps you break it down into meat, deli, produce. Okay, so we're gonna take this. We're going to take the data set, we're gonna insert. We're going to go to slicer, and then we're going to slice it by department to the example that we have. And now we can play around with it. Let's move on to the next one. Drop down. So drop down is another great function for you to know. So what I'm going to do here is I am going to create a drop down function. So what we're going to do is we're going to click. We're going to go to data. We are going to go to data validation, list, source. So this is going to be the source. Okay, so you see how originally it was nothing, but here we have added it. Oh, it went through. Just give me one moment. Save. It went their way, so let me go back and do this one more time. So what you're going to do is you're going to go to data, and then you're going to go to data validation. You're going to look at list. Then you're going to go here and you're going to click OK. And then it shows up the drop down. Okay, let's move to mix one charts. So charts are a critical way of showing your data. So what we want to do now is we're going to play around. So you see, if I click on this data set, then I go to insert and then I click on different chart. For example, this is the column chart. I can also change the colors of it. It doesn't have to be a particular color. And then what I'm going to do is I'm going to continue to play around with this data set. And this time I'm going to create a chart. The chart is created. Then I can play around with it. I can add more information, for example, legends, clean it out. I'm going to try to create another chart now. This time it is going to be a line chart. So you see how we have created different kinds of chart from the same data set. So next, let's move on to the last but not the least, pivot tables. So with pivot tables, what happens is you have a lot of data you want to organize into a similar format like this. So what we are going to do is we're going to take an example. Let's go to the bottom. Click on your data set, go to pivot table. Yep. So this time it gets opened here. Let's organize our data. How do we want to see it? Do we want to see the date by the number of salesperson, or we can change this to have amount, how much revenue was brought in, or we can do product. I'm going to remove this field. I want to focus just on my product. And I'm going to do how many salesperson is dedicated for each product, or I can say how much revenue each product brings. You can do sum of amount. Sometimes what you can do is you can also break it down further, like showing the product, but by each date or month. So this is how you create your pivot table. Now this was a very quick overview of how you can use Excel and what are the key functionalities that Excel offers. We are going to be learning how to use Power BI and what exactly is Power BI. So let us get started. So let's start with looking at the Microsoft training that is available on their site for Power BI. So essentially, Power BI is nothing more than a way for you to showcase your data in a nice format. Imagine having millions of records. How can you show that to a leadership, to a CEO of a company? A CEO of a company is not going to look into millions of record of data. Rather, a simple visualization will help them understand what exactly is going on with the data, which will help them to actually make good data, business-driven decisions. So here you see a visual of a data set that showcases different kinds of data that tells different story. For example, how many total stores are there? What was the year sale? Looking at by chain. New stores, how many new stores were open till date? Then it breaks down into different kinds of charts, visualizations, which showcase a bubble graph, a data set, a bar graph, a map. So let's go down. A data set is the critical aspect of any visualization. Visualization shows you the picture, but the data is the underlying foundation, which has the attributes around particular data set. After that gets translated into a story which is told through the visualization. Reports. Essentially, Power BI is generating different kinds of reports with different kinds of filters to allow the user to showcase their story of data better. So as you can see, there's a bar graph, there's a line graph, there's a chart. So what we're going to do now is we are going to play around with a real example of students affected by COVID-19 school closure. So this is some example that has been given by Microsoft. So what happens when I click on this chart? What shows low income, high income, and low lower middle income. So let's say I click on primary. So as you can see, when I click on primary, the focus goes to primary. And then there's different kinds of clicking I can do depending on what kind of data set I want to see. Then comes affected students by income level, lower middle income, which is 0.72 billion. Now, as you can see, if you click on this, everything goes back to normal. What happens if I click on high income? So you see how the data on the chart becomes extremely specific to the high income, because that is what I want to see. Then it shows affected students by region. East Asia, South Asia. Let's focus on South Asia. So when I click on South Asia, see how things change within the chart. It's telling me the story of exactly what happened, how South Asian students were affected by COVID-19 school closures. Now, if you guys look at the data, total students are reaching over 1 billion, which showcases different data set points through visualization. It shows you a chart for various income level. Then it gets to the bar graph. Then it shows a line chart type, which is more like a slider, status by countries, then affected students by region. So this is the example that was actually on the Microsoft website, which I thought was really good to show visualization. So now we're going to create an actual report using the master data. The master data consists of customer ID, customer name, dates, net sales, customer information, product profit loss information, salesman information, shipment information. So let's get started. So let's start first with the title. So let's say we're going to call this sales summary. So here I am putting it sales summary. I am going to make it colorful blue. Okay, now what we're going to do is we're going to add a visualization. So these are the different kinds of visualizations that are available. We're going to be using different kinds. So here what I am using is a multi-card to show the net sales. So as you can see now, once I put in the field net sales, all of the net sales are being shown here. So that this is net sales. And if you want to format this, you can also format it to like have a different color, let's say blue. And here you have the visualization, but here you have format your visual. Okay, now what we're going to do is we're going to add another visualization. Let's say we're going to add one stacked column. Let's go here. Let's expand it out. Okay, for the stacked column, you need to have an x-axis, y-axis, and a legend. So let's try to play around to see what works better. What happens when we have x-axis as product and y-axis as something to do with sales, net sales? Okay, so this on the bottom, we have the product information, and on the top, we have actually, we have to replace that with product because first we had the product ID. The product ID is actually unique value. So let's not keep that. Let's just have it as product. So here you can see product. Okay, so this is one visualization. Now again, you can format this to show different kinds of effects. Here you can color code this. This one is just good with white. You can add a title. Let's say net sales by product. Let's bold it. Let's make it a little blue. And what else am I thinking we can do? I think this looks good. Now let's add another visual. This time let's play with the donut chart. So you see how I have added a donut chart here? What can we represent with the donut chart? How about we represent profit and loss? Let's see how that comes along. Okay, profit. Now I don't think this is telling the story well. How about we do it by region? So if we want to do the donut chart, we need to have some kind of a data set that really like shows it in a better visual. So here it's showing middle northwest. How about we do this? So we can do product by region. But you can see, and I have added here, I'm just going to go in and I'm going to play around with the title because the title is just doesn't make sense count of product. It rather should be product by regions. And let's color code this Jew blue. Actually what I'm thinking is then maybe what we can do is we can have a different background, maybe something that's light, but not too light so we can see the other things too. Yep, yellow is fine. And let's go back. Let's change this to blue. Okay, so we have the visualization here. Now let's play with something else. Let's create a pie chart. So a pie chart is similar to a donut chart, but they are essentially two different charts. So now let us play around with maybe number of customers by region. Let's see how that comes along. So you have here, let's see. So this is giving us customers by region, and the first one was product by region. What do you guys think? I think this looks good. Okay, so go to chat title, like customers by region. Let's make it blue. Maybe we can try to add another background color as well. Efforts. Okay, let's do purple, no, pink. Even there's like two out there, but I'll just go with then. All right, let's add another visualization. Let's try something different that we haven't done. So there are different kinds of visualization. There's this metrics, there's this clustered board chart, but it all depends like what kind of visual, what kind of story you're trying to tell. Based on our data set, we're playing around to really see what kind of a sales summary we can tell. So what I'm going to do is I'm going to go with this stacked board chart. I'm going to put it here like this. And what should the story say? So how about we try to play around a little bit? What if we do net sales by product? How will that come along? Okay, it's just how about redo it this way? Product 1, product 2, product 3, and then summary of net sales. Okay, because this one was net sales per product, this is also net sales per product, so it wouldn't make sense. How about we get the customer here? Let's see how that comes along. Okay, so how about we try this? No. So a lot of time with visualization, you have to play around to see what works better and what really tells the story the right way. So let's try to do maybe sales by year. Okay, so this is a better data set. It tells us what happened in 2020, 2023, 2024. So I think I'll stick with this one. I'm going to go to title. I'm going to say net sales by a year. And what I want to do is I want to definitely change the heading. Maybe make it blue. Properties. Yeah, you can change any property sign you want. Here, let's go to effects and also add a visual border for this one. And let's make the visual border blue. And let's change the color of this to, right now it's like white, but maybe we can make it a little gray in the background. I think that would help. Yep, like this. The essentially is white, but the gray background is showing a little bit more. Let me just fit this to size like this. Okay, so you guys see like before and after. And what I really wanted to emphasize is that when you're creating a report, it should show different kind of data visualization so the story can be told well. The story essentially is what the data is telling you. What should someone interpret from the data? Because no one has the time to go over millions of records. This data visualization tells the story in a simple format. So hope this was helpful. Learning Python can help you land a job with a great salary and benefits and lead to a rewarding and satisfying career. In various industries, Python developers are in high demand due to the language's widespread adoption. With Python expertise, you can work in fields such as web development, data science, machine learning, automation, and many more. Today's job market requires you to acquire Python skills in order to be competitive and secure great opportunities. So let's get started to understanding the basics of Python. Let's discuss where and how Python is used. Data analysis and visualization. Data analysis and visualization are two types of Python's most popular uses. Among the most popular Python libraries are NumPy, Pandas, and Matplotlib, which provide efficient tools for analyzing, displaying, and manipulating data. Using these libraries, you can clean and process data, perform a stats analysis, create interactive visualizations, and generate insightful reports. Machine learning and artificial intelligence. AI and machine learning have benefited greatly from Python's capabilities. The TensorFlow, Keras, and PyTorch libraries provide powerful frameworks for building and training machine learning models. The simplicity of Python as well as its extensive scientific computing support makes it well suited to tasks such as image recognition, natural language processing, and predictive analytics. Game development. Several Python libraries facilitate the development of games, including Pygame and Panda 3D. Games can be created using these libraries in 2D or 3D. Graphics and audio can be handled, and logic can be implemented. The great thing about Python and its rapid development capabilities is that it makes it an attractive option for prototyping and developing great games. Scripting and automation. Python's ease of use and readability makes it ideal for scripting and automation. Python scripts can automate repetitive tasks, perform system admin tasks, and streamline workflows. The Python standard library provides modules for interacting with files, databases, network, and more, making it a great choice for automating a variety of tasks. Software and hardware scripting. Python can be used for scripting tasks in software and hardware development. In general, it is used for test automation, software testing, and controlling microcontrollers and robots. Web development. Python provides frameworks like Flask that make web development easier. Developers can build scalable, secure, and feature-rich web applications using these frameworks. Developing websites, APIs, and server-side applications with Python is easy and fun thanks to its amazing libraries. Before we wrap up, let's take a mini quiz. What is Python used for? A. Web development. B. Data analysis. C. Game development. Or D. All of the above and much more. What do you think? If you picked D. All of the above and much more, you're absolutely right. Let's start learning Python now. Initially, we will discuss theory, then we will get into practical examples. First, you need to understand the syntax, and then you need to know how to use it. We will cover the following topics: basic syntax, conditional statements, functions, libraries, and frameworks. Just a quick note before we begin to learn how to code. When you speak a language like Spanish, English, or Chinese, you need to know the words and the grammar before you can effectively communicate with other people. Similar to that, before you can build or test with Python, you need to know a syntax, which is more than understanding its basics. You need to know how to use it to actually build it out. Let's learn how to download Python. Follow these steps. Number 1, open your web browser and go to python.org to visit the Python website. Python offers two versions, Python 3.2x and Python 3.x. As of 2023, Python 3.x is the latest stable version of Python. So as step 2, download the latest version. Step number 3, select the operating system on the Python website and you'll find options for various operating systems such as Windows, Mac, and Linux. Click on the appropriate operating systems based on your operating system. Step 4, you'll always be taken to a page where you can choose different options for installing the software after clicking on the download link. Please select the installer file that corresponds to your operating system and download it to your computer. For example, for Windows, download the Windows link. Step 5, run the installer by double-clicking the downloaded installer file. Complete the installation by following the instructions provided by the installation wizard. Step 6, open a command prompt, Windows or terminal for Mac and Linux, and type the following command to check if Python has been installed successfully. The version of Python installed will be displayed by this command. Check that it matches the version you downloaded. Well done. Python has been successfully downloaded and installed on your computer. Now you can write and execute Python programs. Now let's download PyCharm. PyCharm is Python IDE. IDE stands for Integrated Development Environment, which is a software application that helps programmers develop software code efficiently. To download PyCharm, you can follow these steps. Number 1, visit the JetBrains PyCharm website. Number 2, PyCharm is available in 2 editions, PyCharm Community Edition, which is free, and PyCharm Professional Edition, which needs to be paid. Click on the download link for the edition that suits your needs. The PyCharm download page offers options for different operating systems, depending on your operating system, Windows, Mac, or Linux. Choose the appropriate download link. Number 4, to download the installer, click on the link for the edition and operating system you selected. Your computer will begin downloading the installer file. Number 5, download the installer file. Complete the installation process by following the instruction provided by the installation wizard. It may be necessary for you to have admin privileges in order to get the software installed on your machine. Number 6, you can launch PyCharm after the installation is complete by finding it in your applications or start menu. When PyCharm is open for the first time, you will be asked to configure some initial settings. Well done. PyCharm has been successfully downloaded and installed on your computer. For Python development, PyCharm can now be used as an integrated development environment. Now that we understand these steps, let's do a quick review of it, how it can be done. So first we're going to go to a browser and we are going to type Python download. This you have to go to the python.org site and here download based on the operating system that you have. You can also browse through the website to get more information. As you can see, the installer has downloaded, so what I'm going to do now is I'm going to click on it and a wizard should pop up. You can read through this if you want, but I am just going to go to continue for the installation. And then multiple things come up, just mark it as continue. They're going to be asking for your admin information, give them your admin information. Yep, it's just preparing some files. It will take around like 5 minutes for this to go through. After your files have been completed, as you can see it's almost done, there should be Ubuntu resources popping up, which will show you Python files getting installed. Yep, as you can see now, Python has almost installed. It's just running the last few minutes. You see the IDE, the README. Now that it has installed, what you can do is you can mark it as complete and close everything out. Just make sure to keep this. Now what we're going to do is we're going to move on to downloading PyCharm. We're going to put JetBrains PyCharm here. As you can see, you can find it on Google browser. It has popped up. What you're going to do now is just browse to the site and see what other things are available. Now what you can see is that there are 2 types of PyCharm available. One is paid and one is free. We're going to go with the free edition. Click on download. It's just going to take some few minutes, but installation has started. In the meantime, all this is installing. Let's just talk about IDE. So IDE is really important because that is your environment where you're going to build, you're going to test before you actually release something out to the world. Now, what I really want to emphasize is that end user never sees your coding backend, your IDE environment. It always sees what you have developed and brought it to production. For example, if we look at Facebook, no one ever goes to facebook.com and sees like a bunch of code. That doesn't exist. What does exist is that the actual website that has been produced. So just always keep that in mind while you are developing that IDE. Your environment is your environment to build, to make mistakes. But once it goes to production, that is the seriousness that will come. So while we were waiting, I just wanted to bring that up so that it is in your mind. Okay, so now that it is installed, we're going to bring it into the applications file. So it is available to you. Yep, just few things happening to make it sure it's fully in your environment. Now what we're going to do is we're going to search PyCharm. It should be available for you to use. And it should open PyCharm Community Edition. As you can see, it's opening up. The fact that it's showing up and it's opening up, it is a good sign. Just give it another moment. It's going to start. First time it might take a little longer, but once you start to use it, it's just going to be like seconds. So PyCharm is opening up. Yes, say agree. Now let's create a new project. Yep, next. Remember you're going to have like a lot of projects, so that is why it asked you where you want this particular project to be installed. Now let's go to the terminal. In the terminal, what we're going to check is what version of Python do we have. So go to terminal, we're going to put the command python -- version, and if it shows us the version, this means that it has successfully been installed. Okay, everything is working great. We're going to learn about comments. Python code can be explained using comments to a human. It is not code. Code can be made more readable by using comments. Use this simple or the single-line comments and triple quotes for multi-line comments. Indentation. Unlike other programming languages, Python uses indentation, white space, to define code blocks. Code lines are indented with spaces at the beginning. Variables. The Python language does not have a command for declaring variables. Variable types are determined at runtime in Python, which means variables are created when they're first assigned values within the code. A variable is a container for storing data values. Let's talk a little bit more about variables and how to name them. Variables can have short names like X and Y or descriptive names, age, customer name, total revenue. Rules for Python variables. Variable name must begin with a letter or underscore. Variable names cannot begin with a number. Variable names can only contain alphanumeric characters and underscores. The names of variables are case sensitive. Python variables cannot have keyword names. Python allows you to assign values to multiple variables in one line. The good thing about Python is that it allows you to assign values to multiple variables in one line, which saves you time and speed. Global variables. Variables that are created outside of a function and can be used throughout the code and program. We will learn more about functions soon, but right now let's focus on variables. Global variables can be used by everyone, both inside of functions and outside. Non-global variables are specific to only inside of the functions and they have no meaning outside the function. Data type. A data type is an important concept in programming. Different types of variables can store different types of data. In simple terms, data is organized into categories to better use, understand, and process them. By default, Python provides the following type. Text, strings. Strings are sequences of characters enclosed in quotation marks, either single or double quotes. Symbols, letters, digits, and white space can all be used as characters. In most programming languages, including Python, Strings are fundamental data types. The purpose of them is to represent and manipulate textual data. Strings can store words, sentences, paragraphs, and even entire documents. Let's play with strings a little bit. Let's print some strings. As you can see, we created a string variable and printed using print function. There are also the following. Upper method returns a string in uppercase. Lower method returns a string in lowercase. The split method splits the string into substrings if it is finds instance of a separator. You can extract a portion of a string using slicing. Slicing allows you to obtain a substring by specifying a range of indices. You can determine the length of a string, the number of characters it contains using the len function. Numbers. Python has 3 built-in numeric data types: integers, floating point numbers, and complex numbers. Int. An int is a whole number, positive or negative, without decimals, with no limits. Float. Float or floating point number is a number, positive or negative, containing 1 or more decimals. Complex. In Python, complex numbers are a built-in data type used to represent numbers with both a real and an imaginary part. The complex number type is denoted by using the complex keyword or by specifying the imaginary part with the I or J suffix. Sequence types. The sequence data type in Python is used to store in an organized fashion the sequence data. List. Lists are used to store multiple types in a single variable. A list contains items separated by commas and enclosed within square brackets. Lists are mutable, meaning you can add, remove, or modify elements after creating them. Even if the data is in a list format, you can access them individually by indexing. List items are indexed. The first item has index 0, the second item has index 1, etc. Lists are 0 indexed, so the first element has index of 0. The length function gives the length or the number of elements in the list. There are many types of data that can be contained in a list, such as numbers, strings, booleans, and even other lists. As a result of their flexibility and dynamic nature, Python lists are widely used in a variety of applications. Tuple. A tuple is another built-in data structure that is similar to a list. However, unlike lists, tuples are immutable, meaning that once created, their elements cannot be modified. Tuples are represented by comma-separated values enclosed in parentheses. They are often used when you want to store a collection of values that should not be modified. They can also be used to represent a group of related values where the other and structure of the elements are required. Boolean. The Boolean data type represents truth values. There are 2 Boolean values, true and false. Booleans are used in logical operations, conditional statements, and control flow to determine the flow of execution based on certain conditions. Boolean values can also be the results of comparison operators such as equal, not equal, greater than or equal to, less than or equal to, which compares two values and returns a Boolean result. Programming relies heavily on Boolean values, which allow you to control the behavior of your programs based on specific conditions. To summarize, data types are important because data is a critical aspect of the coding process. Note, the type function returns the type of the object, and it will help you understand the data type of variables while coding. Conditional statement. You can use conditional statements in Python to control the flow of your program based on certain conditions. Python's conditional statements include if, elif, short for else if, and else. You need to know these things about Python conditional statements. The if statement. The if statement executes a block of code only if a specific condition is met. Using the if-else statement, you can execute one block of code if a condition is true and another block if the condition is false. The if, elif, else statement. This allows you to test multiple conditions and execute different blocks of code depending on which condition is true. Nesting conditional statements. It is possible to nest conditional statements within each other to create more complex decision-making structures. Using this method, you can check multiple conditions and perform different actions based on the results. The code blocks within conditional statements should be properly indented using spaces or tabs. Indentation determines the scope of the code block in Python. This helps to serve conditional statements in Python. Making decisions based on conditions is essential to controlling the flow of your program. Functions. The concept of Python functions is fundamental to programming. Here's what you need to know about Python functions. Number 1. Function definition. The term function in Python refers to a block of reusable code that performs a specific task. In addition to a name, it may have parameters which are optional and a return value which is optional as well. Definitions of functions are made by using the def keyword followed by parentheses and the function name. Number 2. Function syntax. Def function name parameter 1 parameter 2 is an example of how definitions are set. Function body has a code block and perform actions. This is basically the work that is getting done by the function. And there's an optional return value as well. Number 3. Function parameters. Parameters are placeholders for values that can be passed to functions. By using them, you can make your function work with a variety of inputs. During the definition of a function, parameters are enclosed in parentheses. Number 4. Function arguments. When a function is called, arguments are passed to it. The parameters in the function correspond to these values. When a function is invoked, arguments are provided inside parentheses. Number 5. Return statement. When a function returns a value, it uses the return statement. In the statement, you can pass back a result that has been calculated inside the function. By default, if there's no return statement, the function returns none. Number 6. Function call. In order to execute a function, you must call it by its name followed by parentheses. The arguments are provided inside parentheses if the app function has parameters. Number 7. Scope and global variables. It is important to know that functions introduce their own scope, which means variables defined within them cannot be accessed outside of them. It is possible, however, to access global variables from within a function. Number 8. Default arguments. Function parameters can be assigned default values. A default value will be used if no parameters provided when calling the function. Number 9. Arguments of variable number. Using Python special syntax, you can define functions and accept variable numbers of arguments. Args can be used for non-keyword variable length, and then there is the keyword variable length arguments. Number 10. Recursion. Python functions can be recursive, which means they can call themselves. Solving problems that can be broken down into smaller parts can be made easier with recursive functions. Number 11. Function documentation. The purpose, parameters, and return value of a function should be documented with a docstring, which is a multi-level comment. You will be able to understand how to use the function more easily. Using Python functions, you can organize and structure your code, promote reuse, and make it easier to read. Modules and packages. Modules and packages are used in Python to organize and manage code into reusable and logical grouped components. Python provides a rich library of modules and packages for various functionalities. Here's what module and packages are and how they work. Number 1. Modules. Modules contain Python code defining functions, classes, and variables. The module is designed to be imported and used in other Python programs. It is easier to organize code with modules and to reuse it with modules. Using the import statement, you can use them. The from key can also be used to import specific functions or variables from a module. A module from a package must be imported using Dodge notation. Here are some examples. Number 2. Packages. Packages organize related modules into a directory hierarchy. This directory contains multiple Python modules as well as init.py file. Init.py indicates the directory should be treated as a package. By using packages, you can organize modules into subdirectories and provide a hierarchical structure for your code. As a result, naming conflicts can be avoided and large projects can be managed more easily. There's also a special line file called init.py that contains the package's initialization code. When the package is imported, this file is executed. Also keep in mind, you can create a directory and include an init.py file in it to create your own package. By creating Python files within the package directory, you can add modules to the package. Modules and packages help you organize your code into logical units, promote code reuse, and create more maintainable and scalable Python projects. Here are some examples. File handling. Python's file handling involves reading and writing files. Python offers several ways to handle files. The following are the basic operations. Number 1, opening a file. Using the built-in open function, you can open a file path, and a mode. For example, read, write, append are required. Number 2, reading from a file. The read method allows you to read the contents of a file. The entire file's content is read as a string. If you wish to read a line at a time, you can use read line. Don't forget to close the file when you're done. Number 3, writing to a file. The write method can be used to write to a file. The file can be written with a string. The file will be created if it does not exist. The previous content will be overwritten if it exists. Number 4, appending to a file. You can append content to an existing file by opening it to append mode A instead of write mode W. The write method will then add content to the end of the file without overwriting it. Number 5, closing a file. After you have finished working with the file, it's essential to close it. To release file resources, use the close method. When you have done, the statement will automatically close the file. In summary, it is important to handle exceptions when working with files, as file operations can raise errors. During the file handling operations, it is a good idea to use exception handling using try and except codes. This is a basic overview of how files are handled in Python. In addition, there are more advanced methods and techniques available, such as working with binary files or using the OS module. Error handling. The ability to handle errors is a crucial part of writing Python code that is robust and reliable. The following are some key points to remember about Python's error handling. Number 1, exception types. Exceptions are used in Python to handle errors in exceptional situations. Code exceptions are raised when errors occur during exception. There are a wide range of built-in exception types in Python, including value error, type error, file not found error, etc. You can handle specific errors more effectively if you understand the different exception types. Number 2, try except blocks. Try except blocks are the most common way to handle exceptions. The try block contains code that may raise an exception. If that exception occurs, it is caught by the corresponding exception block based on the exception type. To handle different types of exceptions, multiple exception blocks can be used. With the exception block, exception can be handled gracefully and necessary actions can be taken. Number 3, handling multiple exception types. An exception block can handle multiple exception types if you specify them as tuples. Number 4, handling all exceptions. You can use a bare exception block to catch any exception regardless of its type. To prevent unintentional hiding errors or masking unexpected exceptions, it is generally recommended to be more specific about the exceptions you want to catch. Number 5, handling specific exceptions. An exception block without an exception type at the end can be used if you need to handle a specific exception type, but you also want to catch all other exceptions. In this block, any exception not caught by preceding specific exception blocks will be handled. Number 6, the else block. If there are no exceptions in the try block, then the else block is executed. It allows you to define code to run when the try block succeeds without throwing any exceptions. By doing this, we can separate the error handling logic from the normal flow of code. Number 7, the finally block. The finally block is always executed regardless of exceptions. It defines code that should be executed regardless of the situation, such as releasing resources or performing cleanup operations. If an exception is thrown or an early return statement is made, the finally block ensures certain actions are taken. Number 8, raising exceptions. Raising exceptions explicitly is possible with the race statement. With this feature, you can create custom exception types or raise built-in exceptions with custom messages. When you encounter an error condition that needs to be handled at a higher level, you can raise an exception. Number 9. Logging exceptions. It is often helpful to log exceptions for debugging or troubleshooting purposes, in addition to handling them. Python's logging module provides powerful logging capabilities that allow you to record exception information and other relevant details. To summarize, it is important to understand these concepts and best practices related to error handling in Python in order to write code that gracefully handles exceptions, provides useful feedback, and improves application reliability. Object-oriented programming. Object-oriented programming organizes and structures your code around objects, which are instances of classes. Python supports OOP fully, and here are some key concepts and features you should know about it. Number 1. Classes and objects. A class defines the properties, attributes, and behaviors, methods that objects belonging in that class will possess. Objects are instances of classes. Instances of a class can be created by using its name, followed by parentheses. Classes can be public, private, protected. Number 2. Attributes and methods. All instances of a class share class attributes, which are variables defined within a class. Each instance of the class has its own instance attributes. Classes define their behaviors through methods, which are functions defined within them. Attributes of a class can be accessed and modified by them. The first parameter of instance method is self, which refers to the instance itself. Number 3. Inheritance. Inheritance allows you to create a new class, derived class, or subclass that inherits properties and behaviors from another class. It is possible for the derived class to add or overdrive attributes and methods as needed. Number 4. Encapsulation. In encapsulation, the internal details and implementation of the class are hidden, and data and methods are accessible through well-defined interfaces. It ensures data integrity and code maintainability. To indicate the intended visibility of attributes and methods in Python, use underscores. Number 5. Polymorphism. Here, objects of different classes are treated as objects of a common base class. So, as long as they are implemented, the required interface or method signature, methods can be called on objects without knowing their specific types. As a result of this, code can be more flexible and adaptable. Number 6. Method overriding and overloading. By overriding a method defined in the base class, a derived class can be provided of different implementation. In a class, method overloading refers to the definition of multiple methods with the same name but different parameters. You can achieve similar behavior in Python by using default argument values or by using args and kwargs to accept a variable number of parameters. To summarize, these are some of the fundamental concepts of Python object-oriented programming. It is possible to write more organized, modular, and reusable code by understanding and utilizing these concepts. Libraries and frameworks. In Python development, libraries and frameworks simplify the process of building applications by providing pre-written code, tools, and abstractions. To get started with Python libraries and frameworks, here's what you need to know. Libraries. A library is a collection of modules or packages containing reusable code. You can use libraries to perform specific tasks without having to reinvent the wheel by importing their functions, classes, or methods into your own code. Python has a vast ecosystem of libraries covering a variety of fields such as NumPy for numerical computing and array operations, pandas for data manipulation and analysis, matplotlib, and seaborn for data visualization, requests for making HTTP requests, SQL, Alchemy for working with databases, TensorFlow and PyTorch for machine learning and deep learning, Django and Flask for web development framework. Installation and usage. A library is typically installed using a package manager like pip. To install the pandas library, you would run pips install pandas in your terminal or command prompt. With the import statement, you can import the library into your Python code, such as import pandas as PD. Frameworks. Frameworks provide a foundation for building applications by providing reusable libraries, tools, and conventions. The framework defines overall structure and flow of an application and provides abstractions and patterns that streamline development. Here are a few examples of Python's web development frameworks. Flask, a lightweight framework that allows the model view, root, pattern, and provides a simple yet flexible approach to building applications. Pyramid, a general-purpose web framework that aims for simplicity, flexibility, and scalability. Fast API, a modern high-performance framework for building APIs with automated data, validation, and documentation generation. Installation and usage. Frameworks can also be installed via PIP, just like libraries. Flask, for instance, can be installed using pip install Flask. After installation, you can start building applications by following the framework's documentation and utilizing its benefits and conventions. To summarize, here are the key benefits. Using libraries and frameworks, it saves developers time and effort by providing pre-written code and components. Frameworks offer built-in tools, patterns, and abstractions that streamline development and make complicated applications easier to develop. Python has a rich ecosystem of libraries and frameworks, backed up by a large developer community. As a result, you can leverage existing solutions, get support, and contribute to open-source projects. Libraries specialize in specific tasks or domains, allowing developers to use specialized functionality without having to implement them themselves. Libraries and frameworks offer support extensions or plugins that allow developers to customize and enhance their functionality. Although libraries and frameworks are powerful tools, it's important to choose and use them wisely according to your project needs. To ensure proper installation, usage, and best practices, always refer to the official documentation and community resources. Documentation and community. Documentation and community are vital aspects of the Python programming language that provide resources, support, and opportunities for learning and collaboration. Here's what you need to know about documentation and the Python community. Documentation. Number 1, official documentation. Python's official documentation covers the language itself, standard libraries, and various tools. It explains Python effectively, gives tutorials, and gives examples. Visit the docs.python.org to access it. Number 2, library and framework documentation. Library and framework documentation explains their usage, features, and API references. To understand how to use a framework library correctly, you should refer to the official documentation, like Flask, NumPy. Python community. Python Software Foundation is a not-for-profit organization that supports and promotes Python programming. In addition to managing the Python community, the organization organizes events such as PyCon. Number 2, Python Package Index. Python's official package repository, hosts thousands of third-party libraries and frameworks. It simplifies the process of installing packages and allows developers to share their code. Number 3, forums and mailing lists. There are several online forums and mailing lists where Python developers can ask questions, seek assistance, and engage in discussions. Python mailing lists, Python, Reddit, and Python Discord are among the most popular. Number 4, conferences and meetups. It is possible to meet fellow Python learners and developers by attending talks and workshops, and really to network with Python professionals at Python conferences like PyCon, PyData, and regional and local meetups. Number 5, online learning platforms. For learning and improving the Python skills, there are many online platforms such as pythons.org tutorial section, free code can, W3 School. Number 6, open source projects. Numerous Python projects are hosted on platforms such as GitHub, which has a variety of open source community. Open source projects are a great way to learn, collaborate, and gain practical experience. You can greatly enhance your Python journey by staying up to date with news and developments. participating in the Python community and leveraging the resources available to you.